Okay, let's go ahead and get started with number 1. So it says use the vertex and the intercepts to sketch the graph of the quadratic function. So the first thing you're going to do is that you're going to go ahead and look at up here. So the y equals 1 means that for your vertex, the y value is a -1. And for this, your x value is a +3. So that means if you go down here, your vertex is going to be at 3, -1. Yeah, 3, -1. So that is going to be right here. And then you're going to go ahead and find your x and y intercepts. So your x-intercept is going to be for when you plug in 0 to y and solve for x. So then you're going to have 0 plus 1 equals x minus 3 squared. So you're going to have 1 equals x minus 3 squared, x minus 3 equals 1, x equals 4. So then you're going to go ahead, oh, and this is going to be a plus or minus 1. So it's going to be x equals +4 and 2. So you go ahead to here. So it's going to be at +4 and 2. And then you're going to go ahead and find your y-intercept. So your y-intercept is when you plug in 0 for every instance of x and solve for y. So you're going to have y plus 1 equals 0 minus 3 squared. So then you're going to have y plus 1 equals -3 squared, which is y plus 1 equals 9. So then you're going to have y equals 8 as your y-intercept. So that is going to be right here. And then you can just go ahead and connect your points and draw your graph. And it's going to look just like that. And then for number 2, we are going to find the vertex using the formula x equals -b over 2a. So your b value is this -4, so you're going to have a -4, and then 2a, and your a is that -1. So then you are going to have a 4 over -2, which gives you a -2. So for your vertex, the x value is a -2. And then to find the y, you're going to plug in this -2 back into that equation. So you're going to have f of -2 equals -2 squared minus 4 -2 plus 5. So you're going to have a -4 plus 8 plus 5, which is going to give you a 9. So your vertex is -2, 9, which we can go ahead and put down here. So that's -2 and 9. So your vertex is going to be right there. And then you can go ahead and find your x and y intercepts. So for your x-intercept, just like in number 1, for every instance of y, you're going to plug in a 0. So you're going to have a 0 equals -x squared minus 4x plus 5. So you're going to have a 0 equals, and you can take out that negative sign to make factoring a little easier. So you're going to have a negative and then x squared plus 4x minus 5. Then you're going to have an x plus 5 and an x minus 1. So then your x-intercepts are going to be x equals -5 and x equals 1, which we can go ahead and put right over here. So -5 and 1. And then we can go ahead and find the y-intercepts, which also, like in number 1, is when you plug in 0 for every instance of x. So you're going to have f of 0 equals -0 squared minus 4, 0 plus 5. So that means f of 0 equals 5. So your y-intercept is 5, which is right here. And then you can go ahead and connect all of your lines to form your graph. Okay, so then we'll move on to number 3. So the manufacturer of a smartwatch has found that the revenue R in dollars is R of P equals negative 5P squared plus 1210P. When the unit price is P dollars, if the manufacturer sets the price P to the maximum revenue, what is the maximum revenue to the nearest whole dollar? So kind of similar to number 2, we're going to use the formula x equals negative B over 2A, which is a negative. Your B value is 1210 over 2, and your A is a negative 5. So then you're going to have a negative 1210 over a negative 10, which is going to give you a positive 121. And then you're going to take that 121 and you're going to plug it back into this equation. So then what you're going to have is you're going to have a R121 equals negative 5, 121 squared plus 1210 times 121. Then you can go ahead and put that in your calculator. So you're going to have a negative 73,205 plus 146,410. And then when you combine those, you get $73,205. And then that's the final answer for number 3. So then for number 4, it says determine whether the function is a polynomial function. So for this one, what you're going to do is you're going to look at the exponents of the x's. So for this one, the exponent is a 7 over 5. For this one, the exponent is a 1. And for this one, it's a negative 1. Now, the reason that this x is a negative 1 is because whenever x is in the denominator, it's a 1 here. And then if you were to bring it to the top, you would make it a negative 1. So because this is a negative 1, that means that it is not a polynomial function. So you would say not a polynomial function. Okay, so then for number 5, you have find the x-intercepts of the polynomial function and state whether the graph crosses the x-axis or touches the x-axis at each intercept. Okay, so for this one, the first thing you're going to do is you're going to take out this x squared and try to simplify it. So you're going to have x squared minus 144. So then you know that the x squared minus 144 is a perfect square, or a difference of perfect squares. So it's going to be x plus 12 and x minus 12. So now for this one, you have that, you're going to look at the exponents for all of the x's. So this one is a 2, and then you have a 1 and a 1. So for each x-intercept, so this one is x equals 0, this one is x equals negative 12, and this one is x equals positive 12. So because this one, the x squared, has that squared, it has a multiplicity of 2, which means it's a touch and turn. And then because these ones, the x's with the 12s, they have a exponent of 1, which means that it just crosses the x-axis. So crosses x-axis and crosses x-axis. Okay, for number 6, what you're going to do is it says use the leading coefficient test to determine the end behavior of the polynomial function. So the leading coefficient test means that you're going to go ahead and take the coefficient of the variable with the highest exponent, which is going to be this one right here. So you have a negative 4x to the fourth. So this 4 up top means that it's going to be an even function. So you could say even. And what that means is that they're both ends are going to be going the same way. So ends same way. So that means they're either both going to be going up or they're both going to be going down. Now, because this is a negative, that means that it's going to be going down. So what that means is that both ends, so it's going to be fall right and fall left. Okay, now for number 7, it says graph the polynomial function. So the first thing you're going to do is you're going to figure out which way it's going to be, which way the ends are going to be going. So to do this, you're going to look at the first, like we did in number 6, and you're going to look at the leading coefficient. So it's a positive, so the x to the fourth. The 4 means that they're both going the same way, so it's even. So both ends are going the same way. And then because it's a positive right here, that means they're going to be going up. So that means that it's going to be rise to the left and rise to the right. So rise left and rise right. Okay, so now that we have a picture in our heads of how that's going to go, we can go ahead and find the touch and turns and the multiplicities like from number 5. So we're going to have f of x equals x to the fourth plus 6x to the third plus 9x squared. So we're going to go ahead and pull out that x squared. So we're going to have x squared times x squared plus 6x plus 9. And then you can go ahead and factor that, which is x plus 3 and x plus 3, which then you can change to an x squared and an x plus 3 squared. So then right here you have these two, both of the 2's, which has a multiplicity of 2. So for this one, the x-intercept is x equals 0. And because it has a multiplicity of 2, it's going to be a touch and turn. And this one is, the intercept is x equals negative 3. And because it has that multiplicity of 2, it is also a touch and turn. And then we can go ahead and find the y-intercept. So, and then to find the y-intercept, you're going to just plug in 0 for every instance of x. So that is going to give you a 0 to the fourth plus 6, 0 to the third plus a 9, 0 squared, which ultimately is going to give you that the y-intercept is 0. So now that you have all this information, you can go ahead and graph it. So we'll start with the x-intercepts, which is x equals 0 and x equals negative 3. And we know that these are both a touch and turn, and then we do know that the ends are going to be going up. So that means it's going to be coming down like this, touch and turn, come back down to this one, and go up again. And then you just add your arrows, and that's going to be your graph for this function. Okay, and then we can move on to number 8, which says to divide using long division. So we're going to have this bottom part, and then we're going to have this top part. So that bottom part is going to come out to the outside, so it's going to be the negative 5x plus 3. And then inside the division bar is going to be everything on the top, so it's going to be negative 20x to the third minus 13x squared plus 35x minus 10. So how you're going to do this one is that you're going to look at this negative 5x, and you're going to look at this negative 20x to the third and figure out what you can multiply the red by to get the blue. So you just look at it and you can say to yourself, oh, that's going to be a 4x squared. So then you do the 4x squared times that negative 5, and you are going to get negative 20x to the third. And then you're going to multiply this 4x squared by that 3 as well. So then you're going to get a plus 12x squared. And then this whole thing is being subtracted. So then you go ahead and you subtract. So a negative 20x3 minus a negative, so these are going to cancel. And then you have this 12 turns into a negative. So then you have a negative and a negative, so you just combine them to have a negative 25x squared. And then you're just going to bring down the 35x and the 10. And then you can go ahead and move on to the next part. So you're just going to pretty much do the same thing again, but now with the negative 25x squared and the negative 5x. So for this one, you're going to have to look and see what multiplied by the negative 5x gives you negative 25x squared, which is going to be a plus 5x. So then you're going to have negative 25x squared. And then you have to multiply the 5x by that 3. So you're going to have plus 15x. So then, and it's also like this. So then these two cancel. And this is a negative. So that's 35x minus 15x, which gives you 20x. And then you're going to bring down that 10 again and give you a negative 10. So then you're going to look one more time and you're going to try to figure out 20x times what gives you that negative 5x, which is a minus 4. So then you're going to go ahead and have a 20x, and then you got to do that negative 4 times that 3, so you're going to have minus 12. And that whole thing is being subtracted. So then these cancel out, and this turns into a plus 12. So that's negative 10 plus 12, which gives you 2. So how you would write the final answer is that you would take everything from the top here. So that's going to be a 4x squared plus 5x minus 4. And then you're going to take that 2 that you had left down here, and it's going to be plus that 2 over the negative 5x plus 3. So let me rewrite that to be a little nicer. So you are going to have the 4x squared plus that 5x minus 4 plus the 2 over negative 5x plus 3. And that 2 is going to go over the negative 5x plus 3 because it is the remainder, and you couldn't fully divide it by it. So in your final answer, you're going to have to express that it is still being divided by it. Okay, so then for number 9, it says to divide using synthetic division. So what you're going to do is on the bottom down here, that x minus 12, or sorry, the x minus 2 is an x equals 2. So you're going to have the 2 over here with that little L. And then you can go ahead and write everything on the top, which is that x5. And you're going to have to write down all of the exponents like this. So the 5 and the x and the 3. And then anything that you don't have, like the x to the 4th, you're just going to write a 0 for. So let me go ahead and write that. So you're going to have x5, x4, x3, x2, x, and your constant. So then you can go ahead and write the values for it. So the x5 is a 1, 0, 0, 1, 0, and negative 1. So now you can do the adding and multiplying part. So then you're going to bring down the 1. Then you're going to multiply it by that 2 up there. So then you're going to get a 2 So the 2 plus the 0 gives you a 2. 2 times 2 is 4, plus a 0 is 4. 4 times 2 is 8. The 8 plus the 1 is a 9. The 9 times the 2 is an 18. And then the 18 plus the 0 is 18. And then 18 times 2 is 36. And then 36 minus the 1 is 35. So then what you have is your new value. So this is an x. The 1 is for the x4, x3, x2, x1, and the constant. And then this is your remainder, the 35. So how you're going to write this for your final answer is going to be x to the 4th plus 2x to the 3rd plus 4x squared plus 9x plus 18. And then it's going to be plus, I'm going to write it down here because I ran out of the room, that 35. And because it's the remainder, the original x minus 2 is going to go underneath it. So this whole thing is the right answer. I just ran out of room, so I put the 35 down there. But it should be just on one line. Okay, so then we're going to go ahead and move on to number 10, which is solve the polynomial equation. So part A says, make a list of possible rational zeros. So to do that, you're going to take the one with the smallest x, which is the 6 because it has no x, and the largest one, which is x to the 3rd. So then you're going to do the factors of the 6 over the factors of the x to the 3, which is just 1. So all the factors of x are plus or 6 is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then for 1, it's just plus or minus 1. So all your possible rational zeros are going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, so now for B, it says to find a 0. And how you're going to do that is when one of these possible rational zeros that you just found, when one of those plugged into the equation gives you 0. So I'm going to go ahead and pick 2. This is more, for this part, it's pretty much just pick and guessing, and you just plug them in until you find the one that works. So I just wanted to go ahead and try 2. So if I plug in 2, you're going to get a 2 third to the 3rd minus 7 2 plus 6 equals 0. So then you're going to get an 8 minus 14 plus 6 equals 0. And that is 0 equals 0. So that checks out. So one of your zeros is x equals 2. I personally always like to, whenever I'm doing something with synthetic division or something like this, I do try to start with 2. It usually works out pretty nicely, and if it doesn't, I would then go to 1. So now divide the polynomial with synthetic division. So you have your 0, which is going to be that 2 we found before. So you're going to have the 2. And then you're going to go ahead and, like before in number 9, you're going to list all of the x's. So x to the 3rd, x to the 2nd, x, and the constant. And then you're just going to write them from that equation. So what you're going to have is you're going to have 1, 0, negative 7, and 6. And then you can go ahead and do the bringing down and multiplying. So if you bring down that 1, you're going to get 1 times 2 is 2, plus 0 is 2. 2 times 2 is 4. 4 minus 7 is negative 3. 2 times negative 3 is negative 6, and you have a 0. So then these are going to correspond now with x squared, x, and the constant. So this is going to give you x squared plus 2x minus 3 equals 0. And now that you have that, you're going to solve the resulting polynomial equation. So what you're going to do for that is you're just going to rewrite the one we found in part C. So that's x squared plus 2x minus 3 equals 0. And then you're going to factor it. So that is going to give you x plus 3 and then x minus 1 equals 0. And then you're going to find the x values from that. So that's going to be x equals -3 and x equals 1. So then you're going to state all solutions in part E, which is just all the values you found before. So that's going to be this 2, this -3, and that 1. So all your solutions are going to be -3, 2, and 1. All right, so then for 11, it says find an nth degree polynomial function with real coefficients satisfying the given conditions. So first what we're going to do is we're going to take the 3 and I are zeros. We're going to take this and go ahead and make a function from that. So we have f of x equals the a. Then we have x minus 3, which is this one. And then we have x plus I and x minus I. And for the I, you have to do plus and minus because you do have to remember you did, originally I is from a square rooted equation that had a negative in it. So it could be plus or minus. So then you're just going to go ahead and combine everything. So you're going to have a x minus 3. Then when you multiply the x plus 1 and the the x plus I and the x minus I, you get x squared minus ix plus ix minus I squared. So then you're going to have the a and the x minus 3. So you're going to have x squared. This and this cancel each other out. And then I squared is equal to -1. So then you're going to have a -1. So then to rewrite it, you're going to have a x minus 3, then x squared plus 1. So then what you're going to do is you're going to multiply the x minus 3 and the x squared plus 1. So then you're going to get equals a, and you're going to get x to the power of 3, and you're going to get plus x, and then minus 3x squared minus 3. And then to rewrite that, you're going to get a x to the third minus 3x squared plus x minus 3. And now that you have that, you go and you look back up here where it says f of 2 equals 15. So what you're going to do is that this f here, you're going to now substitute it with f of 2. So you're going to have f of 2 equals, so that means for every instance of x, you're going to plug in that 2. So then you're going to have 2 to the third minus 3, 2 squared plus 2 minus 3. And then that f of 2 equals the 15 like it says up at the top. So you're going to have 15 equals a, and then 2 cubed is 8 minus 3. So 2 squared is 4. 4 times -3 is -12 plus 2 minus 3. So then you're going to have that 15 is going to equal a. So then you're just going to combine all the numbers in the parentheses. So 8 minus 12 plus 2 minus 3 gives you -5. So then you're just going to solve for a, which is you're going to divide that -5 on both sides. So what you're going to end up with is a equals -3. So now that you have that a, you're going to go ahead and plug it back into that equation that you had up here. You're going to plug it back into this equation right here. So then you're going to have f of x equals a x cubed plus x, oops, sorry, x cubed minus 3x squared plus x minus 3. So then you have f of x equals -3. And this one is just the one we found up here. So you have that -3 times the x cubed minus 3x squared plus x minus 3. And then you're just going to distribute that -3 to everything inside the parentheses. So then you're going to have f of x equals -3x cubed plus 9x squared minus 3x plus 9. And that is going to be your final answer for number 11.